Okay, have a quick video today. Just wanted to show how to convert Hugging Face Safe Tensors model to GGUF for Llama.cpp. This is not related to our training project. This is just more for fun because I am lucky enough to get one of these devices, the Nvidia DGX Spark, which was released just recently, I think this week. And it's a very small compute device that's, I would say, geared towards hobbyists and researchers who are interested in doing AI training. And the reason why I say that is because it's not specifically geared towards fast inference because of its memory bandwidth, which we'll see later. But basically, what makes this device special is that it has 128 gigabytes of unified memory, which means that the system RAM and the GPU RAM are shared together. So you actually have a lot more VRAM than your typical personal computer with an Nvidia GPU, which could go anywhere from 8 gigs to maybe as high as 96 gigs, depending on how much money you want to spend. But what's also interesting too is that each one of these DGX Sparks, they have a ConnectX networking interface card, which allows you to connect with very high bandwidth another DGX Spark with it. So you can get double the amount of memory. And then what ends up happening is that now you can train a model that is really, really big. It's like 200 billion parameters. And it's optimized for floating point for compute. And so you might be seeing a lot on the internet recently about people being very disappointed with the DGX Spark, especially for the cost. I personally disagree. I think actually it's a good device if you understand the target audience for it. I would say I am disappointed about the device when it comes to using it as like a inferencing device where I can host a model that I use quite often and connect to it. I was expecting for it to be much faster, but it is still fast enough for most things. It also uses a lot less power too. So yeah, this is a Spark, and it has 273 gigabytes per second of memory bandwidth, which is actually not that very fast. It's much slower than a GPU, but still faster than CPU inferencing here. It has a 10 gigabit Ethernet adapter, but again, the really special thing about this is the ConnectX 7 NIC, which is probably the reason why it's so expensive. It retails for about $4,000. Power consumption is at 240 watts. So anyway, yeah, I have one of these to play with. I'm going to SSH in, and well, not here actually. I think I'm already am here. Yes, I'm already here, and I want to be able to run my favorite coding model in with this Spark so that I can connect it to VS Code using Climb. So in this case here, this model, if I change directory into it, is in safetensors format. And I would like to use Llama.cpp to host this specific model so that I can, yeah, just use it remotely and have the DGX Spark just sitting on a table, just 24/7, being ready to do some coding. And the first step here is to obviously build Llama CPP. And so I assume that that's already done. And what we just need to do is convert these safe tensors to that single GGUF file. So GGUF, is that what we call it? So I'm going to attach to my tmux session, and then we'll go from there. So here I have my tmux session attached to my terminal, and I've split the screen to show the htop statistics and just my working space here. And the reason why I use htop is because NVTop and Nvidia SMI are not going to report all the numbers that we are interested in, especially with like VRAM usage. I think simply because this is not really a GPU, it's more like it's closer to like an APU if you think about it from like AMD. So you want to be watching the system memory in this case here. And here we just have the OS running, which is about 2.5 gigs out of the 120 available to be used. The other 8 gigabytes is most likely just used for swap, and in this case it's probably not using disk swap but rather compressed swap. So yeah, in this case, like, we have our model in this directory, so we just go here, Qwen3 coder. Okay, so this is our directory here. And what we want to do is we want to just copy that because we're going to be pointing to this directory when we're doing the conversion. So if we go to Llama.cpp, for example, I think it's just code repos, Llama.cpp. Okay, we have a script in our Llama.cpp repo called convert. Where is it? Convert here. Convert hf to gguf.py. And assuming you already have your virtual environment running, let's take a look at what that script looks like in terms of what arguments it expects for us. Oops. It would help to do -- help. Okay. So, taking a look at the help message here, the format is going to be convert to gguf.py. It will take in, it'll take in an out file with out file parameter. So that's the GGUF, the path to the GGUF we want to create. And then the input file, which is the safetensors directory. And all this other stuff here, you can just usually leave this as default empty, unless you are trying to create like you're trying to convert something that also takes in vision, so you need the projection file. But for Qwen3 coder, I think we're okay with just providing the output file and the input directory. Out type, we'll just leave it as a default 16-bit in this case. This is the first time I'm actually doing it on the DGX Spark, and what's different is that I'm usually used to doing all this in x86, so this is the first time I'm doing it in ARM. So running the command, convert hf to gguf.py, will provide an out file, and I'll put that in home directory. Okay, and then that would also be my models directory, and I will call it Qwen3 coder 30ba3b instruct.gguf. And then the path to the model would be home. I remember this, models, and then Qwen3 coder 30ba3b instruct. So this is where all the safe tensors are at. So if we run this command, we're going to run through this conversion script, and it's going to convert this 61 gigabyte worth of files into one single big 61 gigabyte GGUF. And so the cool thing about this Spark is that it's actually not, as in reality, it's not too slow, right? Like it's converting at a good rate, but I can also now store this model and run it on one device, on one, like I don't need two GPUs or anything like that. That's the cool part about it. And then we'll look at the performance after we've been able to load the GGUF. So 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 we'll wait for this to finish converting, and then we'll check back in about 1 more minute. Okay, so it's done converting and the model file is now here. So we can actually now run Llama.cpp and point our model, or at least point the server to this specific model here. I like to write a script just to run it, and I'll show you an example. So if I change directory to my models directory and I ls, I will see that the GGUF is here. And so let's look at this run gemma3 4bit.sh as an example. In fact, I'll just copy it so that I can create like a Quen version. Quen3 coder, run Quen3, how do I do this? Coder 30b a3b instruct.sh. Actually, let's do underscores just to be consistent. Okay, now let's go into that, and we'll have this pre-filled already with what I was running Gemma3 4B with. So in this case here, it's not going to be Gemma3 anymore. It's going to be Quen3 coder 30b a3b instruct.gguf. But let's take each line and try to digest it. So this one here specifies to run Llama server. This is -m specifies the model file you want to run. And then and then C here is the context window, how much tokens you want in your context. So I am going to go for the full 256. So I think, is it 262144? I think that's the number. How many layers you want to offload to the GPU? So I put 999, just basically everything. How many CPU threads? Alias here is what do you want to name your model. I'll name it Quen3 coder 30b a3b. Okay, and then the mmproj files if you have a multimodal model, so vision, but Quen3 coder isn't. And then the host and the port you want to run in. So I will run this on port 8000. Okay, so this looks good. That's a very basic setup. Yeah, let's try to see if we can run it. So in this case, I could quit out of this, and then I can ensure that my script is runnable. It already is, but I'll just show you how to do that. So oops, Quen3 coder, where is it? Run Quen3 coder. Okay, so it's just adding the executable permission using chmod on this script. And then after that, we can just try to run the script and see what happens. Okay, so now that it's trying to load the model, we're going to see the system memory is going to climb up. So this will take a while. Yeah, so we'll see it goes up to like 13 gigs, 17 gigs, 20 gigs, 23. And then we also have a large context window. So a full 256K tokens. So it's going to be way more than 61 gigs loaded into memory. I wonder how much, maybe 80 or 70. Let's see. So yeah, it's great to have this much memory, especially in such a small device. I'm actually very impressed, and I think I know you can get the the AMD version too, the Strix Halo on for cheap too. It's like half the price, but the downside is that you won't be able to network them together with high speed networking. You'll be stuck with regular Ethernet in this case, and I do want to one day experiment with networking two DGX Sparks with ConnectX 7, just to see what it is like to have that much VRAM. Things will go slow, but you can run it, and I wonder what it's like to do full like precision fine tuning on some of the bigger models with that much VRAM. So it's curious. Anyway, yeah. So the model itself looks like it's already being loaded into memory. In this case here, I think more memory will be consumed once the I guess KB cache and things are taking into consideration for like all the context window. So yeah, we'll just wait a little longer for that to happen here. As far as like demoing goes, let's just have Klein vibe code a resume website, or like not even resume. Let's do it like an aspiring AI engineer resume, and see where it goes from there. I just want to see the token generation speed in this case. So let's see here. It looks like it was able to load all the way and we have about 85 gigs of VRAM used, and we can connect to this endpoint here. Why not? Let's actually go and see if we can run this thing. So 192.168.1.21 port 8000 is going to be the port, and let's just say hi. Okay, so it does feel fast, and let's I haven't used this in a while. Let's show raw LLM. I want to see, there used to be a thing that shows the tokens per second. They've probably moved it to a different menu. Show model information, render content as markdown, developer, where would this be nowadays? Is it by default? Show tokens per second. Wow, okay, cool. And then keep processing statistics. That's okay. I just want the tokens per second. So let's just have write let's do this. Build me, and this is inspired from Bijan Bowen. I really enjoy watching his channel. He's really cool. He likes to do this prompt as build me or write a browser based OS in JavaScript, HTML, CSS. He does this like prompt that looks like this, and he usually tests like the quality of the output of the LLM based off of that. And since I'm here already, I might as well just kind of just have it generate some tokens and see what it comes up with. So let's see, and it's pretty fast, right? Like as a coding model, this is something that I can tolerate. And so I've had good luck, as you can see from like the other videos of Qwen 3 Coder, and it looks like we're getting 29 tokens per second. But yeah, it's not a bad model, and so the fact that it can do it this fast means that this device is at least usable for a local coding assistant. And additionally, we do have more memory available to run like an even smaller model for something else, right? So we have like 30, I don't know how many, 30 gigs more to just do something with. And so yeah, I don't really understand the hate that's going on. I mean, this is good enough for me, and not like the Qwen 3 Coder 30B is a useless model either. I think it's quite good. So yeah, and especially if we were to fine tune, we would be able to fine tune this entire model. So that's cool. Now, I can't guarantee that this is going to be a high quality output, but it generates tokens pretty quickly, and it sustains pretty well too, because it's getting pretty long now at this rate, but it's still going at a good clip of 29.7. And let's see here, and it's code, and code is very, like, there's a lot of tokens when it comes to code because of yeah, these things may not be common, right? So yeah, I'll pause it. Maybe I'll speed it up, so I'll just leave it here, and then maybe during. Okay, so I totally missed the statistics, but I think it was down to like 27 tokens per second, and this thing was like generating upwards of 16,000 tokens. So this is a really large file, and it's way more than I expected. So let's see if it even works, and I hope it's good. So I'm gonna copy all this content here, and that's a lot. Wow. Okay, so apparently this includes desktop application icons for applications, folders, desktop background with the pattern, start button. Okay, so cool, whatever. Simply copy and paste this into an HTML file. So I will do that. Let's just throw into Notepad, and then let's just paste, and then save it. Oh, not bad. This is not bad. I can see why this likes to be tested with. So this is pretty good for a 30 billion parameter model, and it was not. Let's see. No, of course it doesn't work, but yeah, I would say this is a decent result for a small model. Yeah, I think usually calculators 8 times 9 doesn't even work, but it got the UI. I think with some back and forth, it can we can fix all these things. So yeah, so that's the model. It was not that slow. If we take a look at here, we averaged about 26.74 tokens per second, and we did generate about 15,500 tokens. Okay, so a lot of tokens generated, and I'm glad that I started the model with such a large context window. So next thing is just to connect this with Klein, and in this case it's straightforward. It's just enter in the URL, in this case my local network with the Spark v1, and then compatible API key will be none. In this case this will be Qwen 3 Coder 30B A3B instruct, and then model configuration here, context window size 262144. We do not have image support. Temperature, I don't think it matters too much, but I'll do 0.6, and then I think that's it. So that is that all there is to it? Where's the OK button? I can't remember if this was a thing. Okay, cool. And now we can just make a new text file and say, okay, let's see, act, and then let's save this as OS 2. So I decided to do OS again. So os.html, OS v2. Okay, so save that, and I will say in this os v2.html file, write a beautiful browser-based OS in JavaScript, CSS, HTML, and let's also and check for bugs and fix them. Be thorough and do your best. Okay. Git must be installed to use checkpoints. That's okay. Let's just have it do it all in one go, and we won't backtrack, I guess. I'm doing it on Windows and not on Whistle, so maybe that's the reason why. So yeah, so if I go back here and look at Llama.cpp, it takes a while to process the prompt. It's about 10,000 tokens, it looks like, and here it should start to go. Yeah, so it's going. So let's just let Klein do its thing. It looks slower than I guess in Llama.cpp, but maybe it's because it's being more careful here. We'll see. So we'll just let this go for a bit, and then we'll check the stats here later on. Okay, so it looks like it finished generating everything. So I'm gonna hit save, and I think that'll allow it to proceed and do more if necessary. I did tell it to like check for bugs and things, but woo, another 800 plus line file. Oops, let's see how many tokens that was. Looks to be a lot more, but we'll see. It looks like it's still kind of going. In this case, actually right here is where we're at. Okay, so 23 tokens per second. So it did feel a little slower on this one, but it generated about, I guess, 10,000 tokens in this case. Yeah, 10,000 tokens. So what's it doing now? Let's see. Okay, so it'll review the implementation more carefully to identify and fix any issues. Let me analyze what may be wrong with the current implementation. Okay, so it's trying to run start os v2.html, so probably doesn't know that it's not going to do anything, but let's see what it's trying to do to at least. It said it noticed some issues, and I think it's still prompt processing. Yep. So yeah, maybe for certain things it might be slow, the DGX Spark, but for the most part, if you're not doing big things like this, it's pretty doable. Like quick scripts and things like that. Like for example, for me, I am not very good with bash scripting, so I tend to use code generators a lot to help me with that. And I can see that like putting a small local model on the DGX Spark like this and just having it on tap for anything related to bash would help. So let's see. Okay, so now it's doing stuff, but what is it changing? Oh, okay. So it is noticing some bugs in the implementation. Let's just hope it doesn't make it any worse. So I expect the quality of this result to be better than the one-shot one on Llama.cpp, mainly because it's a coding agent that is doing this. And it also has like a second chance to look at what it has written, so then it can take advantage and like like fix things that way. But let's see the speed right now. So, oh, it doesn't really report the speed here, but it's going, and it looks like only one thread is like truly working. I can't really tell. Maybe because this again, like the hardware is so new that it's hard to get like these observability metrics. But pretty close. It just needs to finish off the last few lines. There we go. Okay, I'll save it. And what was the metrics here? Let's see, prompt progress 92%, 95. Yeah, so it is getting slower because the context window is growing. We have 45,000 tokens to process here at this point. So, okay, great. I think it's trying to start my personal browser. Oh, there we go. Whoa, this is nice. Wow. Okay. This is maybe even better. It is better. Okay, let's see. Equals. Oh, not exactly. Spoke too soon, but it does look better than the first time, but I still can't switch windows easily. What else do we have? Okay, help. Oh, open help documentation. That's like a toast. Okay, system info. Pretty decent. Still not all the way there, but we were able to get stuff working. Oh, one more improvement. Oh, the calculator. So it did find that the calculator wasn't working, so that's great. So I think it's easier to code gen with a coding agent and get the result, a decent result without much effort, than to go back and forth in a chat application. So the more you know. I just kind of kill these terminal windows. A comprehensive test. Beautiful visual design. I agree. I like it. Okay. So it said it fixed the issue with the calculator, right? Let's see if it did that. No, it didn't. Okay. That's fine. Anyway, the whole point of this was just to test the DGX Spark anyway, not really to vibe code. So let's see. So 14 tokens per second. Once the context window starts to become substantial, in this case we have 67k tokens. That's a lot. So yeah, that's a lot of tokens. So most models only go up to like 128k anyway. So I'm impressed that this specific Quen model can go up to 256. Anyway, yeah, that's it. I just wanted to show off what you could do with a Spark. So I'm going to play around a little bit more, but I'll actually use this as like my official like coding local coding agent for the next few days or so into the work week, and we'll see how it goes. I'll probably do a follow up, and I guess if anybody's interested for like the real hardware review and things like that, I can do that too. So yeah, thank you.